Have you ever thought about what goes on inside a modern warehouse? It's an absolutely insane logistical puzzle. You've got this complex dance of sensors, robots, and packages all moving at once. But here's the thing. How do you make that dance even better, even more efficient, without having to shut everything down just to test one new idea? Well, let's get into it. And really, that's the heart of the problem, right? In the real world, big, new ideas can be super slow and expensive to try out. You can't just, nudge a massive piece of machinery a couple of inches to the left and see if it works better. Or can you? Okay, so here's how we're going to break down what Amazon's doing. First, we'll look at the real-world bottleneck that was slowing things down. Then we'll jump into the virtual testing ground they built to solve it. We'll uncover the 3 secret ingredients that make it all work, see the incredible results, and finally, look at why the future of all this is synthetic. All right, so let's start with the big problem. You want to make a warehouse smarter? You need smarter sensors. But figuring out the perfect spot, the perfect angle for every single sensor, that's a huge challenge. So, picture this. You're trying to find the absolute best place for a camera to read a barcode on a package that's zipping by on a conveyor. With the old method, you'd have to physically build a rig, run a bunch of tests, tweak it, move it, run a ton more tests. I mean, this whole process could take weeks, sometimes even months, just for one new design. It was a massive bottleneck. And just look at the difference here. I mean, it is staggering. We're talking about going from testing just a handful of ideas over several months to testing hundreds of different setups in a matter of hours or days. The boost in flexibility is it's off the charts. So how on earth did Amazon's teams actually build a system that could do this? Well, to smash right through that physical bottleneck, Amazon's robotics teams came up with a pretty revolutionary new tool. They call it Sensor Workbench, or SWB for short. And at its core, it's this incredibly powerful simulation platform built on NVIDIA's IsaacSem. Honestly, the best way to think about it is like a super realistic video game, but for industrial engineering. It's a perfect digital twin of the warehouse, where engineers can test out any idea they have instantly and with stunning accuracy. And you don't have to take my word for it. This quote from the team just says it all. The ability to explore hundreds of configurations in the time it used to take for just a few, that's not just an improvement. That's a complete game changer for the entire pace of innovation. So what's the secret sauce here? What makes this virtual world so powerful and so accurate? Well, it really boils down to 3 key technical innovations that all work together to kind of make the magic happen. Those 3 ingredients are a really clever parallel computing architecture, a custom-built pipeline to get 3D models into the simulation perfectly, and using a universal format called OpenUSD as the single source of truth. Let's break down what each of those actually means. So it all kicks off with parallel computing. Basically, instead of the computer doing calculations one by one, SWB uses the muscle of the graphics card, the GPU, to run thousands of them all at the same time. And what does that mean for the user? It means when an engineer drags a virtual sensor around, they see the results instantly. The feedback is in real time. There's no waiting, no loading screens. It's totally fluid and interactive. The next piece of the puzzle is this custom CAD to USD pipeline. Now, engineers design all their equipment using these incredibly detailed 3D models called CAD files. This custom tool is like a perfect universal translator. It automatically converts those super complex designs into assets that the simulation can use, and it does it flawlessly, preserving every single nut and bolt. And the final secret ingredient is using OpenUSD as the ground truth. You can think of this like the simulation's master blueprint, or its ultimate save file. Every single thing that happens, from moving an object to changing a setting in a menu, it all gets recorded in real time. This creates a perfect, shareable save state, which is huge for collaboration. It means a scientist on the team can load up an experiment and see exactly what the engineer was seeing, right down to the last pixel. Okay, so now we know how it works, but let's get to the so whats. I mean, what did this powerful new tool actually let the teams accomplish? The impact was pretty much immediate. Right away, teams could test out sensor positions at lightning speed. But maybe even more importantly, it became this incredible collaboration hub. You'd have engineers, data scientists, and operations managers all jumping into the same virtual warehouse, moving things around, and seeing the results of their ideas together in real time. They even expanded it to simulate things like lighting, so they could test new designs to get better barcode reads, while also making sure the light is totally safe for human eyes. When you boil it all down, what this really means is a massive compression of the innovation timeline. It's like they hit the fast forward button. Questions that would have taken months of slow physical work to answer, they can now get those insights in just a few hours inside the simulation. Now, this is already a huge leap forward, right? But the team isn't just kicking back and relaxing. They're already planning the next evolution for the sensor workbench. And that next step, well, you can probably guess where this is going. It's all about artificial intelligence. The goal is to go from a tool that helps humans test their ideas to a tool that actually starts generating new ideas on its own. The big vision here is to have the AI analyze a brand new warehouse station design and then suggest the absolute, mathematically optimal sensor placements. And that's the really exciting part. It could potentially discover these totally new, maybe even counterintuitive setups that a human designer just might never have thought of. And the ultimate goal is even bigger. The plan is to expand SWB from just a sensor placement tool into a full-blown synthetic data platform. A complete digital world where they can not only test sensors, but also automatically generate huge, diverse data sets to train and validate all kinds of new algorithms long before they ever get near a real physical warehouse. Which leaves us with one last really fascinating question to think about. This technology is creating a perfect digital twin of an incredibly complex real-world environment. So if you can do that for a warehouse, what other complex systems could you simulate, optimize, and maybe even completely reinvent from the ground up? The possibilities really are kind of endless.